Gear Patrol calls their new dive watch the best sub-$500 dive watch. Full stop. Men's Health rated them as the most stylish solar watch in the game. Who are we talking about? It's Movement. They're leveling up your gift giving with the sleekest watches you can buy and the biggest deals of the season. Shop 30 to 50% off Movement's innovative California clean watches, jewelry, and accessories with fast free shipping and returns now at mvmt.com. That's mvmt.com.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 22, for broadcast on the 20th of February 2023. Coming up on SpaceTime, could black holes be the source of dark energy? Another strong solar flare blasts out from the sun. And Moscow delays the launch of a Soyuz rocket following another spacecraft coolant leak. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a possible link between a mysterious force called dark energy, which has been perplexing scientists for decades, and the most powerful objects in the universe, the dark monsters known as supermassive black holes. The findings, which are published in 2 papers in the Astrophysical Journal and the Astrophysical Journal Letters, could solve one of the greatest questions of the cosmos and determine nothing less than the ultimate fate of our universe. Dark energy is the name which has been given to an accelerating expansion of the universe. The universe began expanding outwards ever since its creation in the Big Bang 13.82 billion years ago. Scientists hypothesized that the force of gravity from all the mass in the universe should be slowing that rate of expansion down. Trouble is, it's not. Eventually, depending on the amount of mass in the universe, the expansion would either stop completely, leaving the universe in a steady state of perfect balance, or alternatively, if there's enough mass in the cosmos, then gradually gravity could start to dominate the universe, causing everything to slowly begin to contract again, accelerating faster and faster, until eventually crashing back together in what scientists describe as a big crunch. And that would be followed by another big bang, then another big crunch, and so on. However, during the 1990s, astronomers studying distant thermonuclear Type 1a supernova events noticed something strange. The stars which create these supernovae all explode with about the same amount of mass, and consequently their explosive power and luminosity is about the same as well. So, by using the inverse square law, astronomers could determine how far away these supernovae are. It's like looking at a bunch of streetlights down a road. You know they're all the same brightness, even though the ones closer to you appear brighter than the ones further away. Unexpectedly, however, astronomers found more than 50 of these supernovae were fainter than they should be for their measured redshift. That is, how far away they are. The calculations suggest that instead of slowing down as predicted, the rate of the universe's expansion was actually accelerating. Some unknown force, which astronomers decided should be called dark energy because it's dark and they don't know what it is causing the fabric of the universe, space-time, to expand at an ever-accelerating rate. Now, the idea of dark energy isn't new. It was first invented by Albert Einstein back in 1917. Like most scientists of his day, Einstein assumed the universe was stable and everything was in balance, just as it should be. The trouble is, his own equations were showing him that in such a universe, gravity would become the dominating force, crushing everything together. Einstein felt his equations were missing something, but he couldn't work out what that was. So he invented, well, there's no other way to put it, he invented a fudge factor, an expansion force for the energy density of space. a vacuum energy, in order to counter gravity in his gravitational field equations, creating a cosmological constant in order to return the universe to a steady state. However, Einstein was forced to abandon his concept of a cosmological constant in 1931 after astronomer Edwin Hubble, that's the dude they named the telescope after, discovered that everything in the universe really was expanding away from everything else. Einstein later described his cosmological constant as his biggest blunder. The recent discovery that the rate at which space-time is expanding is accelerating has resurrected Einstein's idea of a cosmological constant, which, if correct, would ultimately lead to a big freeze, in which all the galaxies would eventually expand away from each other, until only our own local galactic group would remain together, in what would look like a very cold, black, and empty universe. And it doesn't end there. A more extreme version of dark energy, called phantom energy, would see the forces involved increase to such an extent that it would eventually lead to what scientists are calling a big rip. A big rip would see the expansion of space-time occur not just on the cosmic scale of relativity theory, but also on the subatomic scale of quantum mechanics, ripping atoms apart into constituent protons, neutrons, and electrons, and even overcoming gluons to rip off quarks. Under the most extreme dark energy theories, that is the ultimate fate of our universe. The other part of this story involves black holes. They're the most extreme gravity wells in the universe, regions of infinite density in zero volume, where the gravitational pull is so strong nothing, not even light, can escape. Stars, planets, gas clouds, and other matter are all attracted to a black hole by its intense gravity, swirling around the black hole in an accretion disk, sort of like water in a sink going around in a circle before it finally goes down the drain. While the material's in the accretion disk, it's crushed and stretched and ripped apart at the subatomic level, in the process releasing vast amounts of energy at billions of degrees, before eventually passing beyond a point of no return called an event horizon. Once inside the event horizon, escape velocity becomes greater than the speed of light, and since nothing in the universe can travel faster than the speed of light, nothing, not even light, can escape a black hole. Here, matter is spaghettified as it falls forever into the singularity, a place where the laws of physics, as science understands them, break down. Of course, not all of the material in the supermassive black hole ends up being sucked into the event horizon. Some superheated matter in the accretion disk is deflected along powerful magnetic field lines away from the event horizon and out towards the black hole's spin axis, where it's accelerated to relativistic speeds and then focused into intense superluminal jets called quasars. Quasars are the brightest objects in the known universe, shining out like beacons in the dark, and visible over distances of 13 billion light-years. Small stellar mass black holes are formed by the death of some of the most massive stars in the universe in powerful supernova explosions, or through events such as neutron star mergers. And supermassive black holes, the biggest monsters in the universe, which are millions to billions of times larger than their stellar counterparts, are found at the centers of most, if not all, galaxies. Now, observations by a team of 17 researchers from 9 countries has concluded that some properties of supermassive black holes point to a likely source of dark energy. The measurements from ancient and dormant galaxies show that black holes are growing more than expected, aligning with a phenomenon predicted by Einstein's theory of gravity. The result potentially means that nothing new needs to be added to our picture of the universe to account for dark energy. Black holes, combined with Einstein's gravity, are the source. One of the study's authors, Dave Clements from Imperial College London, says the team started off looking at how black holes grow over time, and were surprised to find the answer to one of the biggest problems in cosmology. One of the study co-authors, Chris Pearson, from the Science and Technology Facilities Council Rutherford Appleton Laboratory, says that if the theory holds correct, then it will revolutionize the whole of cosmology, because it will finally provide a solution to the origin of dark energy, a solution which has been perplexing cosmologists and theoretical physicists for decades. So you've got to remember, black holes posed a problem to the accelerating expansion of the universe because of their extremely strong gravitational pull. It's hard to oppose, especially at their centers where everything seems to break down in the singularity. The new results show that black holes gain mass in a way consistent with them containing vacuum energy, thereby providing a source of dark energy and removing the need for singularities to form in their centers. The team reached their conclusion by studying 9 billion years of black hole evolution. As we mentioned earlier, black holes increase in size by creating more and more matter, things like swallowing stars that get too close or merging with other black holes. To observe whether these effects alone could account for the growth of supermassive black holes, the team looked at data spanning 9 billion years. The researchers looked at specific types of galaxies known as giant ellipticals. These evolved early in the universe and then became dormant. Dormant galaxies have finished forming stars, leaving little material for black holes at their centers to accrete, meaning any further growth can't be explained by these normal astrophysical processes. Comparing observations of distant galaxies when they were young with local elliptical galaxies, which are old and dead now, showed that the growth appeared to be much larger than predicted simply by accretion of mergers. In fact, the black holes of today are 7 to 20 times larger than what they were 9 billion years ago. Now, that just doesn't make sense. Further measurements with related populations of galaxies at different points in the universe's evolution showed good agreement with the size of the universe and the mass of black holes. These showed that the measured amount of dark energy in the universe can be accounted for by black hole vacuum energy. This is the first observational evidence that black holes actually contain vacuum energy, and that they're therefore coupled to the expansion of the universe, increasing in mass as the universe expands, a phenomenon the authors are calling cosmological coupling. And if further observations confirm this hypothesis, cosmological coupling will redefine science's understanding of what a black hole is. Study first author Duncan Farrar from the University of Hawaii says the findings are saying two things at once. Firstly, that there's evidence that typical black hole solutions don't work on long timescales, and that's interesting in itself. And secondly, that there's now a proposed astrophysical source for dark energy. What that means, though, is not that other people haven't proposed sources for dark energy, but that this is the first observational paper where you don't need to add anything new to the universe in order to provide a source for dark energy. The black holes in Einstein's theory of gravity are the dark energy. Pearson says if this hypothesis holds true, it would provide a solution to one of the greatest mysteries of our time.
If the data and the theory holds, then this is going to revolutionise the whole of cosmology, because at last we've got a solution for the origin of dark energy that's been, perplexing cosmologists and theoretical physicists for more than 20 years now. Our universe started in the Big Bang about 13.5 billion years ago, and the force of that explosion has caused the universe to expand, and the universe has been expanding ever since, with the galaxies flying away from each other. But all the galaxies and stars in the universe, they have gravity, so this gravity is supposed to slow the universe expansion, and gradually the universe is supposed to slow down but not quite stop. That's the universe that we thought we lived in until the late 1990s, and around in 1998 the Hubble Space Telescope found some mysterious results. It was looking at exploding stars in the distant universe and discovered that the universe was in fact expanding slower in the past than what it is in the present, which is contrary to what we believe. In fact, our universe is actually accelerating at the moment, so it's expanding faster and faster. Now, this is a complete mystery. The best theory that we have at the moment is something called dark energy. Now, dark energy pervades the whole of space and kind of acts like negative pressure. So dark energy is actually pushing things apart rather than bringing them together. And we now know that dark energy makes up most of the universe, the stuff in the universe. About only 5% is made up of atoms, so the stars and galaxies, the things that we see around us. About 27% is made up of dark matter, which again we don't really understand, but the rest of it, around 68%, is this dark energy, and it's completely mysterious, and we don't really have much of a theory for it. This is the new theory. So the team of astronomers at the University of Hawaii, working in collaboration with astronomers across the UK and other countries, have found a connection between dark energy and black holes. So black holes are formed when old stars, massive stars, explode and end their lives. They're also found at the centre of most galaxies. Now, when they're found at the centre of galaxies, that we call them supermassive black holes, and they contain millions to billions the mass of our sun inside them. Now, what our team have done is that we've looked at how these big black holes in the middle of galaxies have changed with time. Now, black holes can actually increase their size, they can increase their mass by accreting matter or merging with other things during their lifetime, so we expect them to increase in size. What we found was that this increase in size, this increase in mass was actually significantly bigger than what could be explained purely by astrophysical processes like accreting stuff onto them or merging. So where does this extra mass come from? So the idea is that these black holes might actually contain dark energy itself, and that this dark energy and the black holes are closely coupled to the expansion of the universe, and in fact that black holes might provide the answer to dark energy itself. This is important for black holes because traditionally black holes, if you fall into a black hole, you fall into the middle and you get crunched in the middle in what we call a singularity. Now, a singularity is basically it's a mathematical problem. It's kind of like dividing by zero. You can't do it. We'd like the singularities to go away. And what this new theory does, it provides a way to circumvent these singularities by saying that the black holes contain this dark energy, or this energy from space that Einstein's theory originally predicted. So it nicely ties up the theory of black holes in an evolving universe with Einstein's theory of general relativity.
That's Chris Pearson from the Science and Technology Facilities Council, Rutherford Appleton Laboratory. However, it's worth pointing out that scientists are a sceptical bunch. After all, that's why we have peer review, so they can tear down their colleagues' work and show why it doesn't really work. Astronomer and cosmologist Professor Grant Lewis from the University of Sydney says the studies do reach some interesting conclusions, but the mystery of dark energy hasn't been solved yet.
There's two papers, one of them which I would sort of consider as, very bread and butter science, which is looking at the growth of black holes over the history of the universe. And the other is a lot more speculative. So what the authors do is they look at the growth of black holes and the expansion of the universe. And they find that there is some sort of correlation between the two. They find that there's a relationship, and they suggest that this might be a link between the growth of the black holes and the dark energy, which is causing the expansion of the universe to accelerate. So it's an interesting tale. The correlation is interesting, but of course, one of the rules in science is that correlation does not equal causation. So they've got an interesting kind of relationship that they're trying to understand, and we've got to understand if that relationship truly holds. But then they've sprinkled a bit of speculation on the top, and of course the sexy speculation is what gets the news headlines.
The idea of the singularity no longer being there, how do you feel about that?
Well, so firstly we have to remember that most physicists agree that the existence of singularities, these places where the universe goes to infinity, we think that those are places where our theories break down. So something probably prevents the real sort of infinite density of material in the center of a black hole. So we wouldn't be surprised if they went away. The thing is that these guys don't really develop a theoretical model in which any of this stuff holds together, right? They found a correlation and said these two things must be related. And if they're related, then maybe there's this mechanism by which we can relate them. But again, it's all a little bit hand-wavy in terms of what's causing the correlation that they found.
There's no place for the Casimir effect in this either, which I thought was a real solid piece of evidence towards dark energy.
Well, yes. I mean, so the Casimir effect is, related to this notion of the quantum vacuum, the fact that even empty space contains energy when you include quantum mechanics. And this has been proposed as one of the potential sources of dark energy, except, again, it's a place where the theories don't quite tie together. In fact, they don't tie together at all. And people are very confused about why the quantum vacuum isn't the natural explanation for dark energy. I mean, again, what we have here is that there's a suggested coupling between the two, but there's no real mechanism on the table for how that would happen.
So your conclusions?
Oh, my conclusion is, of course, is that the observational science behind all of this is very interesting, right? Trying to understand the growth of galaxies over the life of the universe is a very important thing that we need to do, because that even relates to our own origin as a planet around a star in a galaxy in the evolving universe. The correlation, it could be interesting. It could be be a signpost towards something interesting. But at the moment, I think we are closer to the speculation side than really, lifting back the curtain and finding out something really deep about the universe.
That's Professor Grant Lewis from the University of Sydney. And this is SpaceTime. Still to come. Another strong solar flare blasts out from the sun, and Moscow forced to delay a Soyuz launch after another spacecraft coolant leak. All that and more still to come on SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
The sun has emitted another strong solar flare as it continues to increase activity in its build-up to solar cycle 25 solar maximum. Solar flares are powerful bursts of energy erupting from the sun's surface. This one was detected by NASA's Solar Dynamics Observatory spacecraft. Flares and solar eruptions, such as coronal mass ejections, can impact radio communications, electrical power grids, navigation signals, and they can even fry circuits in spacecraft and increase radiation doses for astronauts. The US Space Weather Prediction Center, operated by NOAA, says this flare created a temporary radio blackout over South America. This flare was classified as an X1.1. It originated from a sunspot called Active Region 3217. And just a day earlier, another solar flare blasted out an X1.0 event from a different region. The classification system for solar flares divides them according to their strength. The smallest are classified as A-class, which are near background levels, hardly noticeable. They're followed by B, C, and M-class, and finally X-class, which are the most powerful. It's a logarithmic scale, similar to the Richter scale used for earthquakes, or the Fujita scale used for tornadoes. So each letter represents a 10-fold increase in energy output. That means an X is 10 times as powerful as an M-class flare and 100 times as powerful as a C-class. And within each letter class, there are also finer numeric scales ranging from 1 to 9. The largest solar flare ever recorded occurred back in 2003. That was an X28. Our sun goes through regular 11-year solar cycles, during which time the star gets increasingly violent as it approaches solar maximum, or solar max, at which point the polarity of its magnetic poles suddenly flips. The North Pole becomes the South Pole, and South becomes North. It then gradually quietens down again to solar minimum, at which point the cycle begins anew. The last solar minimum occurred in December 2019. It marked the end of solar cycle 24, which, by the way, was unusually quiet. However, the new solar cycle 25 appears to be starting off far more actively. The next solar maximum is predicted for mid-2025. This is SpaceTime. Still to come. Moscow forced to delay a Soyuz launch after another spacecraft coolant leak. And later in the science report, paleontologists discover a new previously unknown species of giant dinosaur in Argentina. All that and more still to come on SpaceTime. Moscow has been forced to delay the launch of a rescue Soyuz spacecraft to the International Space Station after a Progress cargo ship docked at the station suddenly sprang a leak, spewing coolant into the vacuum of space. This follows a similar coolant leak aboard the Soyuz M22 spacecraft in December, which prompted the Russian Federal Space Agency Roscosmos to organize an unmanned rescue Soyuz to fly up to the space station to collect the crew, rather than forcing them to travel in the damaged Soyuz. The rescue Soyuz was to launch on February the 19th, but following another coolant leak, this one in the Progress cargo ship, which is very similar to the Soyuz spacecraft anyway, has led mission managers to decide to wait a while to see what caused this latest leak. Roscosmos blamed the December coolant leak on a micrometeoroid impact. But the idea of two micrometeoroids hitting the same components on two different spacecraft, that's a bit hard to believe. And that once again raises a common issue with Russian spacecraft of quality control. Both Russian and American mission managers are now troubleshooting the latest issue. Moscow says the hatch between the space station and the leaky Progress has now been locked, so the incident isn't affecting the orbiting outpost. But there are still concerns. After all, the coolant is most likely ammonia. Russia won't say, but that's what we think. And ammonia can be highly corrosive if it gets in contact with metal, and there's a lot of metal on the space station, so everyone's hoping this stuff floats in the other direction. For now, temperatures and pressures aboard the space station are within normal operating parameters, and according to mission managers, there are no dangers to the health and safety of the crew. NASA says all space station systems are nominal, and they're not tracking any other issues. The crew, who were informed of the cooling loop leak, are in no danger and are continuing with normal space station operations. The leaky Progress cargo ship, the Progress 82, arrived at the space station on October 28, loaded with fresh supplies and equipment. The depressurization occurred on the same day that another Russian cargo ship, the Progress 83, arrived on station after launching a day earlier from the Baikonur Cosmodrome in the Central Asian Republic of Kazakhstan. The Progress 83 is delivering some 3 tons of food, water and fuel, along with scientific equipment for the crew. Moscow has now launched a commission of inquiry to establish exactly what's happened to the Progress 82 and to see how similar that is to last December's coolant leak aboard the Soyuz M22 spacecraft. Meanwhile, its replacement, the M23 Soyuz, is sitting on the launch pad at Baikonur, waiting for the go. Moscow says until the cause of the emergency situation is determined, no decision will be made on when to launch the rescue Soyuz MS-23. This is SpaceTime.
Fargo, the new virtual assistant from Wells Fargo, makes banking faster and easier. Like this.
Fargo, what's my checking account routing number?
And this.
Fargo, turn off my debit card.
And this.
Fargo, what did I spend on groceries last month?
And that's just the beginning. Do you, Fargo? You can. In the Wells Fargo mobile app. Learn more at wellsfargo.com/getfargo.
Terms and conditions apply. Your mobile carrier's availability and message and data rates may apply. Wells Fargo Bank, N.A., member FDIC.
And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study warns that the Antarctic and Greenland ice sheets are set to cause major sea level rise once the world passes above 1.8 degrees Celsius warming above pre-industrial levels. The findings, reported in the journal Nature Communications, warns that sea level rise resulting from the melting ice sheets alone is likely to add about 1.4 metres. The authors set out to improve models predicting how much these giant ice sheets would contribute to sea level rise should the current rate of high emissions continue, taking into account the complexities of how the ice sheets interact with icebergs, the oceans, and the atmosphere as they melt. Researchers say the two ice sheets alone, Antarctica and Greenland, are expected to each contribute about 60 to 70 centimetres of global mean sea level rise over the next 130 years, with large areas of the ice sheets lost irreversibly. Scientists say people who have both been infected with COVID-19 and vaccinated against the disease wind up having sustained protection against hospitalisation and severe disease, even if they end up catching another round of the virus. The findings, reported in the Lancet Medical Journal, are based on a systematic review of studies looking at how effective long-lasting immunity was after infection and vaccination. The researchers found that immunity from previous infection alone appears to last longer and be more effective than vaccination alone, but the combined immunity from both was the best. Over 6.8 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. The World Health Organization estimates the true death toll from the virus is now likely to be around 16 million, with some 678 million confirmed cases globally. Paleontologists have discovered a new previously unknown species of giant dinosaur in Argentina. The discovery, named Chicarasaurus diripienda, represents a new species of a colossosaurian titanosaur sauropod, a large herbivorous dinosaur with an elephant-like body and legs, a long tail at one end, and a long neck and small head at the other. Just think of Fred Flintstone's pet Dino. The fossils were unearthed at a dig site in the Rio Negro Formation of northwestern Patagonia and date back some 93 to 95 million years to the late Cretaceous. Among the fossils found were a 1.9 metre long femur, as well as a humerus, ischium, and a tibia. Titanosaurs are among the most massive terrestrial animals to ever walk on the Earth, with some species weighing over 70 tonnes and reaching 37 metres in length. Well, it seems the latest conspiracy theory to be doing the rounds on the internet's less reputable chat rooms and websites are claims that the Artemis project is part of the same hoax that faked the original moon landings back in the 1960s and 70s. Now, let's get one thing clear. There is an insurmountable accumulation of facts, figures, eyewitness reports, documents, images, official and independent studies and reports, lunar rock samples, and scientific instruments left on the moon that are still being used today to erase any doubt that people went to the moon, they walked on its surface, and they came back. But still, there are some people who simply refuse to believe it. For the scientists and engineers who worked on Apollo and those now working on Artemis, it must all seem like proof that stupidity doesn't skip a generation. Tim Mendham from Australian Skeptics says the lunar landing hoaxes remind him of the flat Earth people.
Anything about the moon apparently is sort of a fair game for moon landing deniers, even if this thing didn't land on the moon. But they start denying that these things ever happened. They're in a cleft stick. If they denied in the first place that the Apollo missions never happened, they then have to continue that view through and through. Because as soon as they say, see, they did land on the moon, and therefore it's okay, you ask, well, why couldn't the previous ones, right? And the evidence they put forward is particularly poor. It's been debunked over and over and over again, obviously with the moon landing since 1969. But of course, you have to point out that, do you know when the first moon landing was?
First human landing or the first
No, first moon landing, first craft.
Controlled or crashed?
Crashed.
Crashed, that was the Russians. That was, what, 1959?
59, yes, exactly. And the first controlled landing was 66, so that was the Russians as well. So, yeah, no, so there have been landings on the moon.
Just little spheres with Soviet flags on them. That's all.
Well, then the Americans started doing the same thing. In 1966, there was at least one Russian and one American to land on the moon, but it's a controlled landing. Now, they weren't taking off again and coming back. That's true, but that's what you had to have when you're landing people on the moon. But landing on the moon has been happening for longer than the Apollo. Controlled landings has been happening at least several years before the Apollo landing. So they have to answer for that. I presume they didn't happen either. So the moon landing deniers are really in a difficult position because they now have to deny every moon landing, especially when they start, at some stage, even though they're put aside as sort of sacred territory, at some stage revisiting the original landing sites. But of course, then again, they'll claim that's a filmed on a studio thing. So really, moon landing deniers are just repeating themselves over and over again, and anything that looks like it might come close to, like Artemis, or lands on the moon, like the Artemis projects eventually will, they have to say it never happens. And you think, after a while, it gets boring, quite frankly.
What do you think they do that? What's their motivation for denying the moon landings?
I think it has to be suspicion of authorities, pure and simple. I can't see any benefit. I mean, one suggestion was it was a purely political action to ruin the Russians, that the Americans were claiming the moon landings, so the Russians had to follow suit, which they didn't. They didn't land anyone on the moon.
Oh, but they couldn't.
Yeah. Well, they kept having problems, but the Americans had problems too with aircraft.
Yeah, but they persisted. The N1 just was, at the time, just too complicated to succeed. I mean, one lifted off, but it didn't go far before it crashed again.
Yeah.
That was the problem. I mean, the N1 was a mighty rocket. Really, what we're seeing now with SpaceX is mimicking a lot of what the N1 was going to be. Dozens of rocket engines at the base, and controlling them back in the 1960s was just impossible. Nowadays, we have computers that can do that.
Yeah. and it will become, I presume at some stage down the track, a commonplace. As the Americans suffered, actually, or the TV coverage suffered when the Apollos were landing and coming back, and it became a ho-hum almost. But obviously not for moon landing deniers. They will still be out there. They'll still be putting forward their same theories as to why these things were, or as to how these things were faked. Why they're faked is almost as inexplicable as the people who believe in the flat Earth. Flat Earthers, I can't understand why they would believe it, or why they want to believe it.
Well, that comes back to government conspiracy theories again, doesn't it?
Yeah, probably, but this is not just government.
NASA controlling the Earth, so the whole spiel.
Yeah. But the whole spiel is because it just becomes ridiculous when you realise how many people were involved in the moon landings?
Maybe 500,000 people were involved in that, and they all kept silent about it. Everyone.
It's amazing, isn't it? I've never heard any secret go so well kept. And of course, there were all the people watching it, like, the Russians were watching it, right? Obviously.
The Russians were looking for a fake. They wanted it.
Yeah, and they would have told everybody if they figured it was a fake, but they didn't. So, all these hundreds of thousands of people.
The laser reflectors on the moon, someone had to put them there because we use them all the time to measure how fast the moon is moving away from the Earth. So there's just so much data, the reams of data. The evidence is just overwhelming. You can honestly say only an idiot would deny the moon landings took place or the Earth is flat.
Yes. There's strange arguments being put forward by
absolutes, and they're them.
Yeah. There are some things that are sort of, you really have to wonder why. I can believe. You can understand why someone would believe in ghosts, right?
Yeah.
Supernatural life after
the JFK conspiracy.
Yeah, I can understand. There's a lot of conspiracies that...
Especially nowadays, considering what the CIA have been up to.
Yeah, I know, because people do conspire.
Yes.
Governments conspire, companies conspire, you name it, lots of people can conspire. Keeping a conspiracy secret, is a hard job. As we know, all the conspiracies that are revealed. Keeping it secret in this particular case, where there's just 500,000 people involved, is just ridiculously difficult and unlikely. So it must be just I don't believe anything the government tells me, or NASA tells me, or that the Russians tell me, or that anyone else tells me.
Is it a special knowledge type thing where people who are insignificant in their own minds have this special knowledge in their own minds that they know something that no one else knows? So they must tell everyone about it.
That is the $64 question as to exactly why people believe in a sort of secret knowledge, a club that they might, sort of unofficial club they might belong to, their own animosity to people in general or the governments, etc. All sorts of reasons why people, their own weaknesses, their own disbelief in chance of bad luck, if you like, all sorts of things that, there must be a reason why things happen, or in this particular case, why they don't happen. And I think finding that out is a case-by-case basis. You really have to look at the individuals as to their motivations. But overall, some motivations are harder to find than others, and certainly flat earthers and to a certain extent moon landing deniers is the evidence is there, and they just refuse to look at it. They just look the other way.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Space Time with Stuart Gary. This has been another quality podcast production from Bytes.com.